Okay, so in R2 and R3, there is an easy way to classify all subspaces. This is all there is. Yeah, there is nothing else. So for R2, you have the simplest subspace containing just a zero vector. And then you have lines through the origin, and you have R2 itself. For R3, you have an additional possibility, planes through the origin. That is all we have. To get an idea of why, I mean, this requires proof, of course. Maybe I can give you an idea of why this might be true. If you think about R2, so let's have a candidate H that we know is a subspace. Okay, does H contain a non-zero vector? Well, if it doesn't, then H must be this guy. Let's say it does have a non-zero vector. If it does have a non-zero vector, then it must have, because of the subspace conditions, it must contain the span of that non-zero vector. Now the question is, does it contain? It either contains another vector that is off the line, or it doesn't. If it does contain another non-zero vector off the line, well then this H must contain this line as well. And in fact, H must contain everything, because if you think about it, the span of these two vectors is going to equal all of R2. Conversely, if H does not contain a non-zero vector that is off this line, well then H must fall into this category. So that was a bit rough, but it's the general idea. Okay, there is no subspace in between these possibilities. So you can see these possibilities are all kind of flat, linear, right? They're all have a flatness to them, lines and planes. Even R3, you can think of that as being flat. Okay, let's do an example here. Here's something that is not flat. You have a parabola, x is equal to y squared. So it looks something like this. Now, why is this not a subspace? Well, take your pick. You can see it. Drawing a picture is not a proof, but it can give you an idea. If I have a vector that is on or in H, and I double it, you can see I'm no longer in H. Okay, so visually I can see that if I take a U at random that passes this test, then I will have my counterexample. Okay, so just choose some U that passes this test. Let U equal 2 and then 4 for the X. Or not, doesn't matter. So we'll just state U is in H, because 4 is equal to 2 squared. That's why. But 2U, I'll put a but. But 2U, which is 8, 4, is, let's do this shortly, is not in H, right? since 4 squared does not equal, let's back up here, 8 is not equal to 4 squared. So to say it in long form, therefore H is not closed under scalar multiplication. And thus is not the subspace of R2. Okay, I don't think you have to write that much. You do have to write enough to convince me that you understand what's going on. I guess that's my criteria. Okay, so you cannot be too brief, but you have to be clear. And my main thing when I'm marking especially these questions is to look at what you've written and ask myself if you are getting lucky or if you really understand.